Wow, can you believe we're already 2/3 through the quarter? This is the lesson for week 16. We're going to be talking about systems of linear equations. A system of equations is a collection of two or more equations with the same set of unknowns. In solving a system of equations, we try to find the values for each of the unknowns that will satisfy every equation in the system. Basically, that means that if I draw this line and I draw this line, they'll cross somewhere, and where they cross is the solution to the system because it's part of this top equation and part of the bottom equation. So let's go ahead and solve this. I'm going to first do the top equation. Okay, so this one is y equals 5/8 x plus 9. And remember, when you have the form in the y equals mx plus b, you're going to place the y-intercept first, and then you're going to use the slope to come up with the next point. So this is a 9, so I'm going to go up here, 2, 4, 6, 8, 9, and then it's 5/8. So typically I would go up 5 and over 8, right? Rise over run. The slope is rise over run. But since I can't go positive, I'm going to go negative, negative, and I'm still going to end up with a positive slope. So I'm going to go down 5, 1, 2, 3, 4, 5, and then over 8. 2, 3, 4, 5, 6, 7, 8. So these are 2 points on our line. So hopefully I could graph this very nicely. Okay. And then our next equation, our next equation I'll do in purple. Hopefully it will come through. So y equals mx plus b. My y-intercept is 2, so I'm going to go up to 2. And the slope is negative 1 over 4, so I'm going to go down 1 over 4, which is the same as going up 1 over 1, 2, 3, 4. Up 1 over 1, 2, 3, 4. Oh, look at, they cross at the same spot right here. Right? So that point where they cross, which is negative 8, 4, that is the solution to the system of equations. The system of equations, I have 2 equations, so where they cross is the answer. All right? So we're going to do the same thing. We're just going to graph. So remember, we have the form y equals mx plus b. This term out here is my b, or my y-intercept, where we're going to cross the y-axis. So I'm going to come up here to 6. And my slope is negative 1 over 2. So I'm going to go down negative 1 over 2 in the positive direction, down 1 over 2 in the positive direction. And I can kind of double check that because my slope is negative and my slope is negative when the line is facing this way. Let's do the next equation. We're graphing. This time my y-intercept is negative 3, so we're going to come down to negative 3 and we're going to put a point. And my slope is the same, down 1 over 2, down 1 over 2. Okay, so that line is going to be the same, just like this. And when will these lines cross? Well, to me they look like they're parallel lines, and they are parallel lines. What's the thing that you notice especially is that you see how these slopes are the same? When we've already talked about in our mathematical career that when slopes are the same, they are parallel. So there is, I'm going to write parallel lines do not cross. Therefore, there is no solution because there's no point where those 2 lines are the same. Now, it's nice to be able to graph and see a picture of when 2 lines will cross, but that's not always the best and the easiest way to solve it. Another way to solve is using substitution. Okay? Using graphing may not always be the ideal way due to inaccuracies with graphing. A method called substitution solves a system algebraically, and it works better. So what we're going to do is substitution, and this b right here is just like a little typo, just ignore it. So let's do this first problem. What we're going to do is we're going to do substitution. So see y equals 2x minus 11 and y equals 4x minus 17. Well, I'm basically going to take this portion right here, since that's equivalent to y, I'm going to plug it in there. So we get 2x minus 11 equals 4x minus 17. And in this equation, we can easily solve. Now, we're going to move all the terms with x's onto one side and move all the plain numbers on the other side. Now, I can either subtract 4x or I could subtract 2x. Now, it doesn't matter which one you do, but if I subtract 2x, it's a little bit nicer choice, only because 4 minus 2 is a positive 2x. So I want to keep my x positive. This is a negative 11. Make sure to bring that negative down with that. And so I want to try to keep my x positive. So here what I'm going to do is I'm going to add 17 to both sides. And we're going to get 2x equals 17 minus 11 is 6. Divide both sides by 2. And you get x equals 3. Well, that gives us half of our solution. So I'm going to take that 3, and because I want to find the point where these two lines cross. I could graph it, but you know what? 2x minus 11, my graph doesn't even go to negative 11, so that would be hard to do on these graphs. I found out algebraically that x was equal to 3. How do I find out what y is? Well, I'm going to take this, I'm going to come all the way back to the top, and I know y is 2x minus 11, and I get y equals 2. I'm going to plug in the x. 3 minus 11, so I get 6 minus 11 equals negative 5. So the solution is 3, negative 5. Some of you might be thinking, well, how did you know to plug it in the top one or the bottom one? It doesn't really matter. Notice I could have plugged 4 times 3 because x is 3 minus 17, and I'd get 12 minus 17, which is also negative 5. So it doesn't matter which equation you plug it into. I just happened to pick what I felt was the easiest of the two equations. But our goal is to find the coordinate point where the two lines cross. So this is our final answer right here. Now it's nice when you see these two equations, they both say y equals something. You basically just set those two equations equal to each other and solve. Very simple. Let's look at the next one. The next one, we're also going to do algebraically, but it's not quite as simple. It doesn't just say y equals something and y equals something. So I'm going to actually take this term right here. I'm going to plug it in for y. So I'm going to rewrite the bottom one. Negative 4x minus 2 times whatever y equals, which is 6x plus 4, equals 24. And then we're just going to solve using the skills we learned in Integrated Math 1. Negative 4x, I have to follow the orders of operation, PEMDAS, parentheses, exponents, multiplication and division, addition and subtraction. And we have to go ahead and do anything in the parentheses first, and which now means multiplying this negative 2. So negative 12x, negative 2 times 6, negative 2 times 4 is negative 8 equals 24. Negative 16 minus 8 equals 24. We're going to add these two together. Oops, yeah, sorry, negative 16x. Negative 16x. Okay, let's add 8 to both sides. We're going to get negative 16x equals 32. Divide both sides by negative 16. And we get x equals negative 2. Nice. So now we came out with a nice even number. Negative 2. We're going to come back here and plug it in. Now, which is going to be the easier equation to plug x into? Obviously, the top one, because you're just going to get y equals 6 times negative 2 plus 4, which is y equals negative 12 plus 4, or y equals negative 8. And now we know that our point is my x is negative 2, my y is negative 8. And that is our final answer on that problem. Let's look at the next page, which is just practice. So this is your homework, page 2, and you're going to do the first two problems by graphing. So it's all in the form of y equals mx plus b, so it should be pretty easy to graph and see where those two cross. And the other equations are, here's two y's set equal to each other, Take this y and plug it into that equation. So this one you'd get, I'll have to actually help you out with here. 2x minus 3 equals negative 17. Now there's a negative in front of that set of parentheses, so don't forget to distribute it. And on this problem, it says, oh, let's solve this equation for y first. So down here, if I add 5x to both sides, add 5x, you're going to get y equals 5x minus 7. And so now this term right here is what you're going to plug into that y. All right? Pretty easy homework. I will see you on Zoom.